All right, everybody, welcome back to another episode of the P2E Inferno Speedrun Ethereum challenges for our ongoing Sepolia Odyssey campaign, where we explore different ways that we can interact with the blockchain on a testnet, which is free and completely cost less so that people can get to know a little bit more about the blockchain without having to worry about not being able to pay for stuff. And this is the Speedrun Ethereum Challenge series where we go through uh, different challenges on the Speedrun Ethereum website so that developers can learn how to build on Ethereum by completing these challenges. And this way, you would be able to gain the foundational knowledge and experience to build advanced applications on Ethereum. So, we've been doing this for a couple of months now. We've been doing new challenges each month, and this month we're going to be taking on the DEX. So, without further ado, let's get straight into it. So, to get started, you're going to head over to speedrunethereum.com as always, and if you don't have an account, you can just connect your wallet, and that's really all it takes. And then you can click start building on Ethereum. But we are not going to be doing challenge one because we are way past this. So we're going to scroll over and you can see the different challenges that has been done. And so we are going to take this on, build a DEX. So first thing you want to do is go through the instructions for the challenge. And so we simply just have to read through this as always, just so everyone can get an idea of what is going on. So, challenge 4, build a DEX. This challenge will help you build or understand a simple decentralized exchange with one token pair, ERC20, Balloon, and ETH, Ethereum. So, this repo is an updated version of the original tutorial and challenge repos before it. So this one is pretty much like a modified version. The original one, there's a link that you can click to get to it if you want to check it out. But we're going to be moving on. Please read the intro for a background on what we are building first. Yeah, that's the same thing I said. You definitely want to read to get an idea of what you're doing. So, the final deliverable is an app that allows users to seamlessly trade ERC Balloon with ETH in a decentralized manner. Users will be able to connect their wallets, view token balances, and buy or sell their tokens according to a price formula. Deploy your contracts to a testnet, then build and upload your app to a public web server. Submit the URL on speedrunethereum.com. There's also a YouTube video that may help you understand the concepts covered within this challenge. So, meet other builders working on this challenge and get help in the Telegram channel. So there's a Telegram link here to connect with other builders that's working on this. And I would recommend every one of you that's working on this, check that out so that you can get some guidance if you get stuck, or you can just find other people that's working on the same things that you can connect with and learn together. So without further ado, let's jump straight into the checkpoints. So checkpoint 0, your environment. You want to make sure you have everything that you need set up, and you're going to need Node, Yarn, and Git. So once you have all of that, you definitely want to click on this, copy the command, head over to your code editor, and just paste that in there. So we've got this. I've already seeded to my projects folder, so I'm just gonna hit npx and let it do its thing. Close this out. So I'm using Cursor, and Cursor is a great AI code editor that allows you to be a lot more productive as a developer. So if you're not using that, you definitely want to check it out and try to integrate that into your workflow as a dev. It helps you be a little bit more productive. It's not a substitute for learning how to code. You definitely want to learn the foundation and the basics. So I'm going to sound like a broken record talking about this all the time, but obviously it's really important. So you guys are going to have to listen to me say that for a couple more times before it moves into the background of my mind. So while we wait for this to go on and install, we're going to circle back to this place and just go a little bit over what we're going to be doing here today. So the essence of doing this walkthrough is not to do all of the activities for you guys, so you have absolutely nothing to do and you can just come here and copy pasta the the code and be like, you know what, I did it. I completed the challenge. No. So we are simply just going to help you understand the task at hand, do some of the checkpoints, and that's when we stop so that you can go ahead and complete the rest of it so that your developer muscles and brain cells are being challenged and they're being built out. And this is going to help you as a developer gain the necessary skill and experience that you need to be able to build advanced applications and all sorts of ideas that's going to come into your head or people, clients, and projects can reach out to you or you can join all different teams to work on different complex projects. And so taking the time to do this yourself is really the first step for you to be able to do all that stuff. If you want to be a blockchain developer and if you want to start building decentralized application as we advance further into the frontier of the internet. So right now we've got AI coming up and now we have AI agents that are doing all sorts of cool things and this is just the start of this revolution and at a point AI and AI agents are going to be on the blockchain which will make them completely autonomous and powerful. There are already some autonomous agents that can really do things. But once you get into the blockchain, which is the open internet with permissionless token transfers and interactions with smart contracts, then you have all kinds of amazing things going on. So you definitely want to learn how to build these things so you can obviously stay relevant as a developer and an engineer in the future. So we have our app installed. So we're going to CD. I'm going to click on this and CD to challenge. Looks like my terminal is stuck for some reason. Look, weirdest things always happens on these calls. Sometimes stuff that never happens on a normal day. When we do these calls, it just happens. And I'm like, what in the world is really going on here? So I'm gonna hit that challenge for a DEX, clear this out, and I definitely want to kill that terminal because it was stubborn and it died on me. So now that we've seeded into the folder, we want to just go ahead and copy all these commands. We want to do yarn chain in the same terminal. In the second terminal, we're gonna hit yarn deploy, and in a third one, we're gonna do yarn start. So I like to open from this one, so it's going to start in the same folder. So I'm going to click this and split my terminal into three. And then for this, I'll go ahead and type yarn chain to start my local chain. And this, I'm going to do yarn starts to start the front end. And I didn't just do the yarn deploy because the local chain hasn't started. It just started now. So I'm going to do the yarn start and here I'm going to do a yarn deploy. So we can click on this link to head over to the front end and see what our DEX looks like. So it won't let me copy it. So I'm just going to come here and type localhost 3000 and scroll a little bit down to see what our instructions are. So I've opened this up, it's loading in the next tab. And what does this say? We run yarn deploy whenever you want to deploy new contracts to the front end. If you haven't made any contract changes, you can yarn. If you haven't made any contract changes, you can run yarn deploy dash reset for a completely fresh deploy. All right. So checkpoint one, the structure. Navigate to Debug Contracts tab. You should see two smart contracts displayed called DEX and Balloons. Well, this hasn't loaded yet, so we can't go to that tab. I'll go ahead and read. I think it's doing that now. Well, what's the next thing? Next thing is we head over to Packages, Contracts, Balloon, and we want to see the example. So packages, hard hat, contracts, balloon.sol is just an example ERC20 contract that means 1,000 balloons to whatever address deploys it. So let's go see the debug contracts tab. I didn't even take a second to look at what we've got going on here. I guess I will circle back to this a little bit later, but let's see what we've got going on in the debug contracts. And let's also open up the folder. And I just hope that didn't really close out our terminal. Oof, maybe it did. Yep, it did. So we're going to go ahead and do all of that again. One, two, three terminals, yarn start, chain. Sometimes it doesn't hurt to start over, so yeah, we're gonna have to wait a little bit more for all this to load up. But while we're here, we should do what they said. If we scroll to the hard hat contracts, we can see two contracts. One is Balloon, which is just a simple ERC20 contract importing the ERC20 from Open Zeppelin, and it's inheriting the contract here. And then over here in the constructor, we basically define the constructor arguments as the name balloon, the symbol bow, and we mint the person calling the function, which is whoever is creating the tokens, 1,000 balloons. And for the DEX, we've got the attribution, the title, the author, stefam.eth and moonpoppy.eth, and a little notice for you, the developer, notice dex.so, empty dex.so that just outlines what features could be part of the DEX challenge, up to you. We want to create an automatic market where our contract will hold reserves for both ETH and balloons. These reserves will provide liquidity that allows anyone to swap between the assets. All right, so I think that should be loaded now, the front end. So yep, we've got this to look. And yeah, we have two contracts, the balloon and the DEX. All right, so let's head back here. And as we always do it, we like to use the Speedrun Ethereum instructions as our source of truth and our guide. So if ever we're lost and don't know what to do, we come back here and we just try to read the instructions and figure out what it's saying and what we have to do. So navigate to the debug contracts. You should see them. We've seen that. We've also seen the balloon, and we were looking at the DEX. So what does it actually say we have to do? What we will build in this challenge, and you can see it starts instantiating a token interface that we set in the constructor on deploy. So the next thing is below is what your front end will look like with no implementation code with your smart contracts yet. The buttons will likely break because there are no functions tied to them yet. So if we head over here and we go to the DEX tab, it should show us our interface, waiting for this to load. So this is what it looks like without any functions yet. We have a nice interface. I think this shows our balloon balance, and this might be our ETH balance. And this is the contract. This is for interacting with the balloon ERC20 token. So let's hop back here and see. All right, they're telling us some good stuff. You've made it this far in Scaffold E challenges, and a little round of applause. If you've made it this far, you deserve it. It's not easy to hop in the builder space and keep building, and you don't stop. You just keep forging ahead. As things get more complex, it might be good to review the design requirements of the challenge first. Check out the empty.dex.sol file to see aspects of each function. If you can explain how each function will work with one another, that's great. The guiding questions will lead you in the right direction, but try thinking about how you would structure each function before looking at these. The code blobs within the toggles in the guiding questions are some examples of what you can use, but try writing the implementation code for the functions first. So that's a bunch of instructions for you guys to take into consideration before doing anything so that you can also challenge yourself to really think and really build this out. So let's move on. Checkpoint 2, reserves. We want to we want to create an automatic market maker where our contract will hold reserves of both ETH and balloons. These reserves will provide liquidity that allow anyone to swap between the assets. Let's start with declaring our total liquidity and the liquidity of each user of our DEX. So, all right, let's come over to the DEX contract. So we've got some variables that instantiates the token. We also have some events, ETH to token swap, token to ETH, liquidity provided, liquidity removed, and the contract. The constructor takes in the token contract address, and that's all it does. So we've got some functions here with it's just a did someone say something? You might want to mute yourself. You can mute yourself and try to follow along. We're really just getting started, so you haven't really missed much. So moving on, I was just saying that the contracts are that we have in the contract. We just have the function definition. Captain, you might want to mute yourself. All right, so I had to take some time to mute that guy because he kept interrupting. So I'm gonna go ahead and share the entire screen again. All right, so here we have, notice initializes. What this function does is it initializes amount of tokens that will be transferred to the DEX itself from the token contract T, and only them based on how balloon.sol is written. Loads contract up with both ETH and balloons. So it says it takes in the token amounts to be transferred to the DEX, returns total liquidity. Total liquidity is the number of LPTs minting as a result of deposits made to the DEX. Note, this is a ratio of 1 to 1. This is fine to initialize the total liquidity with respect to balloons as equal to ETH balance of contract. So where do we start? Let's get back to our source of truth and figure out what we need to do. They told us a bunch of things here, but nothing really said anything about what we need to do. So we have to keep reading on to find out exactly what we need to do. We want to create an automatic market maker that will hold, okay, we've been through this. So guiding questions. Question 1, how do we declare a variable that represents an amount of ETH? We don't have to assign it. We don't have to assign it a value just yet. Question 2, what data structure represents the relationship between keys and values, addresses to liquidity or users to ETH? Well, that gives us some hints about what we need to do. I'm just scrolling through the contract to see what else is there. So right now, this is where we go ahead and put our global variables. And so we're talking about total liquidity. You want to put in the data type, and it's unsigned integer. So it's uint 256, and it's total liquidity. And cursor is really helping us here. So I'm just going to go ahead and type it out. So we just declare it, we don't assign it a value. And for the second one, which is liquidity, is going to be a mapping of users. So it's a mapping of address because we're mapping a user to a certain amount of liquidity. So it's an address to uint 256, and we're gonna call this liquidity. So what are we doing here? There we've got two guiding questions that's supposed to help us think about how we want to do this. And the first one is how we declare a variable that represents an amount of ETH and we don't have to assign it. So basically, ETH is just a number. And so that's a huge number. So we're going to use the UN256, which is why we did that here. And we're going to call that total liquidity. Easy peasy. And for the second one, it's a question of what data structure represents the relationship between keys and values, addresses to liquidity, or users to ETH. So key, address, value, ETH. So that is the user as an address to the amount of ETH as a number. And so that's how we have that. So now, after thinking through the guiding questions, have a look at the solution code. So we have our solution code here, but we've already figured that out. So we can now go ahead and look at it. So, oh, we didn't put the visibility. Let's see if there was no indication of the visibility of the variables, but yep, it's public so that anyone can see it and interact with it. So we're gonna head back over here and add the visibility to both of them. So these variables track the total liquidity, but also the liquidity of each address. Now let's create an init function in the DEX. We want this function written in a way that when we send ETH and or BAL tokens through our front end to a deploy script, the function will get those values from the contract and assign them onto the global variables we just defined. Now we go again to the guiding questions. And for this, we have four. So click on question one. How can we check and prevent liquidity being added if the contract already has liquidity? Question two. What should the value of total liquidity be? How do we access the balance that our contract has and assign the variable a value? Question three. How would we assign our address to liquidity we just provided? How much liquidity have we provided? The total liquidity, just half, three quarters. What did we do? And finally, what's the final question? How we need to take care of now, rather. Now we need to take care of the tokens and it is receiving. How do we transfer the tokens from the sender, us, to the contract address? How do we make sure the transaction reverts if the sender did not have as many as the wanted to send? These are really important questions. So we're going to go ahead and take them one by one. How do we check and prevent the liquidity being added if the contract already has liquidity? So obviously we want to check if this is greater than zero, the liquidity, because if the contract already has liquidity, this is going to be greater than zero. And this is initializing the contract. So we're going to head over to here and say, all right, there are no custom errors, so we're going to use the traditional if or require. We're going to use the require. If we had custom errors, we would use if, and then we would revert with the custom error. But since we don't, we're going to say total liquidity greater than zero. So definitely this is a check if the contract already has liquidity. So what this means is if the total liquidity is greater than zero, then this init function is going to revert with a message the DEX already initialized obviously, because right now it's at 0. So that's how we check to prevent this from happening. The question 2 is, what should the value of total liquidity be? How do we assess the balance, and how do we assess the balance that our contract has, and I'll assign the variable a value? What should the value of the contract be? I think maybe we should make it 2 ETH. So we're going to use the call to send ETH rule success. And so we're going to say, so basically what we're going to do is this. We're going to quit coming here. We're going to say, uint 256. Yep, this is, so we're going to say the ETH amount that we want to add as the total liquidity. We're going to give it to a variable called ETH input, and we're going to say it's equal to the message dot value. And basically transfer, we want to make the call to this and send it the ETH inputs, which is this. And we also want to say the total liquidity is equal to this. And we also want to require access. And this is, we're mapping the tokens, not ether. So I'm going to remove that. And let's see, total liquidity. So let's go back and check exactly what we're doing just to be sure. So what should the value of total liquidity be? How do we access the balance of our contracts? How do we access the balance that our contract has and assign the variable a value? So let's say we want the value to be 2 ETH. So maybe we definitely want to add a check for that. So since the ratio is 1 to 1, this is fine to initialize total liquidity with respect to balloons as each. So the ratio is 1 to 1. And first off, if we check over at balloons, we are having 1,000 balloons. So maybe we're going to initialize with 10. So maybe we can just do require. This is not necessary, but I just want to make sure that we're adding a liquidity that is going to start with the amount we want. So require ETH input is greater than or equal to 10, should be at least 10, should be 10 or more. So now what that means is, what should the value of total liquidity be? 10. How do we access the balance that our contract has and assign that value variable? So, all right, so now we've got this going on. Let me see. I think we're still going to have to do the token transfer here. So we're going to still go ahead and do the token transfer. And as a rule of thumb, you want to do the state changes before the contract interaction. So before we go ahead and send, after doing the checks, then we're going to do the state change, which is this, and then we go and do the contract interaction. So next, we also want to do is require for the token amount. And since we're already doing some values up here, so we are still going to do the same thing. Tokens input is equal to tokens. Oh no. So let's just say ETH amounts. What's the word that was used? I'm just going to call it uint 256 initial liquidity. Initial liquidity is not ETH input, 10 ether, and then I'm gonna say initial liquidity. All right, so that way everything looks clean. So first we also require that the tokens obviously is greater than or equal to the initial liquidity. Then we're also going to go ahead and do a transfer. So we're going to call the tokens transfer from, which is the ERC20 standard, where we do the tokens, the transfer from the message that sender, whoever is calling the function, and and we're transferring this and we're transferring the token amount. So definitely what we actually want to check is not that this is obviously that the amount is more than the initial liquidity because we're doing a one-to-one, but we actually want to check that the balance of which was the third condition or the fourth condition that they talked about in the points is we want to check that the balance of the person, which is the MSG, the sender, is greater than or equal to the tokens. So that's it. And then now we want to do the state contract interaction up here. Oops, contract interaction down here. Then we want to do the state change of the MSG, the sender, equal to tokens, not ether. All right, so just to be sure that everything we did is correct, I'm going to go ahead and look at this function a little bit more one time. So initializes the amount of tokens that will be transferred to the DEX itself from the ERC20 contract minting, and only then based on how balloons is written, loads up the contract with both ETH and balloons. All right, so tokens amount to be transferred to DEX and returns liquidity. Total liquidity is the number of LPTs minting as a result of deposits made to the DEX contract. All right, so now here we've done this. How can we check and prevent liquidity being added if the contract already has liquidity? Check. What should be the value of total liquidity and how do we assess the balance that our contract has and assign value? Check. So we're able to check the balance. So we can check the balance obviously with the total liquidity because it's zero. We've already checked. So if the contract has gotten past here, we know that it's zero. So by using this variable and assigning it this, we've definitely answered this part of the question, how much liquidity we have provided. How do we assign our address, the liquidity we just provided? That's also done. How much liquidity have we provided? The liquidity, the total liquidity, just half, three quarters. We basically provided the total liquidity. And question 4. Now we need to take care of tokens. Init is receiving. How do we transfer the tokens from the sender to us? That's one. How do we make sure the transaction reverts if the sender did not have as many tokens as they wanted to send? That's 2. All right. So we've done all that. We checked that the contract didn't have any tokens before we called this. We also checked that the amount is greater than the initial liquidity which we want to send. So we don't just want to initialize the contract with any random amount. So the requirements didn't explicitly ask for this, but there was a question that was asking about how much liquidity do we want to do it with. So we just decided we're going to do it with 10. And so we have to check that the initial liquidity is at least 10. And we also check that the tokens is the same because it's a one-to-one. Actually, we want it to be exactly the same. We want it to be 10. We don't want it to be more or less. We want it to be exact. So we're just going to say it's exact because it's one-to-one. We don't want a situation where, because right here, since the ratio is 1-to-1, so we want to ensure and enforce on the contract that it's a 1-to-1. So we're just going to say it's equal to initial liquidity must be 10. So not 10 or more. All right. So then we are going to require the balance of is equal to the amount here. And then we're going to do this equal to that. And we're going to update the liquidity as well. And finally, we're going to do the transfer from. Then we're going to transfer the E to the contract. and we are going to return total liquidity. And that is all about that. So let's see what the solution code has. Obviously, not as much as what we have, but it's if total liquidity is 0, it means it's already initialized. So we had that. So the total liquidity was assigned to the contract balance, and the liquidity of the contract was assigned to the person calling the function, and then they do the transfer from, they do require transfer tokens successful, and obviously there's no transfer in this, but they basically do the same thing. So the thing is with this, there's always more than one way to do it. So we're going to go ahead and deploy this and see how it works. So by hitting yarn deploy, just to check the deploy scripts. All right, that looks good. So now I'm going to head over here, debug contracts, DEX, connect my MetaMask. So MetaMask is having a hard time opening up. I'm probably gonna shut it down. Wow, MetaMask doesn't want to open up. I'll do that again. And finally, our Foxy friend is coming up, or is it? Because we're having this insanely long loading screen, which is typically not normal. So we are obviously out of time because the hour is up, but we want to go ahead and test this before we wrap this up. So going to try to see what is going on with the MetaMask, and I'm gonna pause the screen share for a bit and try to debug this little MetaMask problem. Close it, and I'm still gonna close it because I closed it and it opened itself up, and that was pretty wild. But I shut it down again, and now I'm gonna start it up and open it up, and finally it looks like it's working. Okay, so I'm gonna head back over here. Finally that worked. Now we're gonna go connect our wallet. Hopefully it doesn't cause any more problems. It just connects the wallet. So this is really strange. Probably some sort of network problem going on here. So I'm gonna try to disconnect my network and refresh the page and try again. Well, we've got an address on here, and I'm just gonna spam the faucet button to get a lot of test E. And so first I'm gonna check my balloons and see how much balance I have. Copy this address. So the address has 0 balloons. So let's click on that and head back to the deploy script. So we're going to say await balloons dot transfer. Okay. Yeah, we're going to transfer amounts. We're just going to transfer 100, and we're going to do it to this address. All right. So we should redeploy. Oh, I forgot I wasn't even sharing that part of the screen anymore. I wasn't sharing the terminal, the code editor. So I'm gonna go back here, switch to share the entire screen, and head back. So I made a change here in the contract. This is the deploy script for balloons. So I came here and added this line to transfer 100 balloons to the front end address, and then I redeploy the contract. So I think now we should have, and we don't. Let's see what's going on. We don't accept any, we just send some balloons to the deployer, and the deployer obviously is here. So this should definitely work. So what we're gonna do is we're gonna log this in the console to see what's going on. cons txn. Then we're gonna console.log to front end, not deploy app. So now let's do a reset, make sure everything is starting over. Now we expect this to have some balloons. Oh no, it's not the right address. Still, that's not what I'm seeing here. So we have this copy, and the address I'm seeing here is not the same. So obviously that's why that wasn't even working in the first place, because I don't know where I got that address from, but it was not the right one. So we're going to do this again. So now we definitely should have the right one. So I'm gonna paste this in here. All right, so we've got our 100 balloons. We've got 24th local testnet ETH. So let's go ahead and initialize. Where's initialize? Wait, isn't that a public function? It is public, so oh, I'm looking in the wrong contract. I'm looking in the balloon. So I'm gonna come up to the DEX, look at the right one. I'm just gonna say 10, 10. All right, so let's inspect our function, obviously, to see what's going on. I think there's a problem here. This line should be the problem. Remove that. And so I think that was a mistake. We still want to return total liquidity. So let's go over this one more time. This is the input, and we make sure it has. So what's a little confusing about this is the liquidity variable, whether or not it should be ETH or tokens. It's a bit confusing, but since it's said to be one-to-one, we can work with it. But I think that's the only change we needed to do there. And now we're going to redeploy the contracts and go check it out. First, we check this. Next, we come here. Now it's reloaded. Copy the address. Let's hope it works this time. Fingers crossed. Boom, more problems. All right, so let's see what they're talking about, the encoded function signature. So this is an ERC20 problem, which is because we're trying to transfer tokens, ERC20 tokens from our contract, from our like our wallet, which is this, to the DEX contracts, and it doesn't have the permission to do this. So basically what we're supposed to do, we're supposed to approve the balloon. Sorry, we're supposed to approve the DEX to spend our tokens. So here's where we're going to do that. We're going to come to the balloon contract, put in our DEX address, and we're just going to approve the DEX to spend 15 tokens. And we do that, it works out nicely. Then we're going to come back here and do this. And so it works now. And now the DEX has a balance of 10 ETH, and also our account has a balance of 90 tokens because we've transferred 10. So let's go check out the DEX interface and see what it looks like now that we've got some balance in there. And I guess you can see this has changed. We now have a nice graph curve thing finely balanced between token reserve, ETH reserve, and you can see the DEX now has 10 ETH and 10 balloons, everything perfectly in the balance. So someone could come now to our DEX and swap balloons for ETH, and now the price will change because there would be more balloons than ETH because they put in balloons and they took out ETH. So there's less ETH and more balloons. If someone came with more ETH and deposited that and took out balloons, then the price would also change, and that's how you have the whole automated market maker DEX thing going on. So that's where we're going to pin our flag. And obviously, there's a bunch more checkpoints to go through, but I'm going to leave that for you guys to take on. And you can see the way we went through it. When you hit a snag or a problem, you come back to the source of truth, you go to the code, you follow the errors. So if we didn't follow this, probably would have been we wouldn't have remembered that we needed to do the allowance, which is an ERC20 token thing. We needed to do the approve, which is something that sometimes you might forget. So it's always good to go through the errors to try to figure out where it's coming from. So what are the next checkpoints? Then just we've got just goals. Checkpoint three is the price. Is there any more? I think finally there's trading. Checkpoint four, checkpoint five. So we've got like four more checkpoints. So, and then before you have to deploy and ship the front end. So Verso or IPFS, and then you can share your link for anyone to interact with your application at that point. So this is obviously more challenging than the other ones that you guys may have taken on. If you've had to try the token vendor or any of the previous challenges, you realize that things are getting more challenging as you goes so that you can test yourself even more. So definitely excited to see how you guys handle this one. And if you run into any problems, you can always reach out or you can join the Telegram and slug it out with other builders that's working on the same challenge and the mentors that's there as well. So with that, I'm just gonna say thank you for joining once more on the Sepolia Odyssey, and I will see you on the next one.